Engineers solving problems. All right, guys, today I'm going over a reading schematics presentation that you will see, and we are going to make circuits based off of this particular schematic. Now, we're going to ignore the fact that this is for a breadboard for now. We're just going to do the schematic. All right, so in Tinkercad, you go to Circuits, and we're going to create a new circuit. And the parts that we see over here is a battery of some sort, a resistor of some sort, and an LED of some sort. We could tell this is an LED and not a diode by the arrows that come off of it that show that this is giving off light. So the way this works is we are going to put these parts out first. So let's go grab us a 9-volt battery. Let's see, positive's on the right side. Let me flip that back. We have a resistor. That's what this part is right here. And then we have an LED. And I'm going to flip the LED. And then I'll close this and I will zoom in so you can see it better. So the way that this schematic works is this. First, you take the positive side of the battery, and this black line that runs right here is a wire. It connects the positive side of the battery to one terminal of the resistor. And since resistors are not polarized, you can hook it up any way that you want. It doesn't matter if you connect it to the terminal 2 or terminal 1. To keep it looking neat, we're going to go with terminal 1. Now, from the resistor, it flows through the resistor, and there's where this blue box is, there is an LED that connects right here. So you take the second terminal of the resistor, that's the opposite side, and you're going to connect to the anode of the LED because current only flows in an LED in one direction, and that is from anode to cathode. So you connect to the anode this way, and now you have from the positive end of the battery to the anode of the LED. Now the last connection that we have to make is where this particular box is, and I couldn't tell you what color that is. I'm colorblind. So from this side, the cathode runs in a wire to the negative side of the battery. So just like this, and you run it down and connect it to the negative end of the battery. And that is your circuit. And when you simulate, the LED should turn on. All right, so that's that schematic. Now we're going to move to the next schematic. Alrighty, so in this particular schematic, all that we want to do is use a switch. So I explained this the other day. A switch is like deleting a wire. If you take this wire out, you have an open circuit, meaning that no current can flow. And when you simulate, nothing happens because current can't flow from the positive end because there's a gap. Well, a switch is the same thing. It makes or breaks a circuit. So if we just get a, we'll get the push button because it works similar to this particular schematic symbol here. You could use the slide switch if you wanted to, or you could use the dip switches, which you could connect a lot of things to. And I don't know where they are. There they are. There's a single dip, 4 dip, and a 6 dip. And these are just 6 switches in a row, and they're real tiny, and they're tiny in real life too. All right, so the way the switch works is from your battery, we have a wire that runs to one side of the switch. This switch is not polarized, so you could either use terminal 1 or terminal 2. So I'm going to move the switch up like this, and we're going to go from the positive end of the battery to terminal 1 on the switch. Now the way the switch works, if you remember in the video that or in class, I said that you have terminal here that's connected internally and terminal here that's connected internally, and there's a piece of wire or metal that's underneath that when you push the switch it connects both sides, which is the same as closing this switch and allows current to flow through. So back to our circuit, we have the positive connected to this end of the switch. So we use the other terminal. You could either use that one or you can use this one. It doesn't matter. They're both the same. So we'll connect that to the switch, to the resistor. And everything else is the same. The difference between this one and this one is just that there's a switch. It's the same schematic otherwise. Then when you simulate and push the button, then the switch closes, creating a path for current to flow to our LED. All right, so we're going to do one more schematic, maybe two. There's time for two. I'm going to delete the switch for just a minute, and we're going to create a battery that connects to the resistor. So that's positive to the resistor. And then current flows through the LED and back to the battery. So what happens here with the switch? Let's go get our switch back. So we'll scroll back up and get our push button switch. I'll just drop it in the middle here for now. And we're going to drag it to the side, and I'll show you. We're going to take this and we're going to rotate it just a little bit so it looks kind of like the schematic. So this looks similar to the schematic. If you're OCD and want all these wires to look right, you can. I'm not OCD, but I'm going to make it look like the schematic. I could take this and put it at the top to show you, but there's not enough room on the screen. But what this switch does is it could possibly create a short around the LED. So what we're going to do is take from terminal 1 and connect it to this end, the anode of this LED. And the other terminal, we're going to connect to the cathode of this LED. So you can see that I've done a pretty good job of representing the schematic almost in the same form in this circuit. So now the question is, if we short circuit this, what's going to happen? Now the hint for this is that electricity tends to follow the path of least resistance. A resistor is going to take, the LED right here is going to take a certain amount of resistance to get the voltage or the current to flow through it. So when you toss this switch or throw the switch or you make this particular connection, the current is going to want to go this way because there's a path of least resistance. So it's going to go from here through the wire, through this resistor, and go this way and bypass your LED. So real quick, what do you think is going to happen? Well, if you're not pushing the switch, the LED is going to be on this time. But if you push the switch, the current is now flowing through the switch instead of the LED, and it turns off. All right, so that's that particular circuit. Let's stop simulation. Let's do one more, and then we'll call it a day, because there's one more that you guys are going to do here. This is just to help you in case you are lost. So this particular circuit has 3 LEDs in a row. Well, that's pretty easy. We're going to go get 3 LEDs. So we'll paste 1, 2, 3 LEDs. So if you look, let's follow the path of the wire. We have positive connects to the resistor. Positive connects with the wire to the resistor. And then that resistor flows to the first LED's anode. Well, that flows to the first LED's anode. Then we go and connect this anode to, or this cathode to this anode of the next LED. Well, that's cathode to anode. And now from this LED, you go from this cathode to the next anode. So you can look over here, cathode to anode. And then from here, you have a cathode with a wire that's connected to the negative side of the battery. And there's your circuit. When you simulate, all 3 LEDs turn on. All right, so since there's time in this video for one more, I'm going to go ahead and show you the last one. This particular schematic exercise is using a breadboard. So it has some of the answers on it, but we're just using the same one to look at the schematics to see how are these made. So we're going to delete these wires for just a minute. There's a difference in this one. It has 3 resistors. So we're going to disconnect the whole thing. We're going to make 3 rows with our LEDs. We're going to make 3 rows with our resistors. Or actually, these are also columns, I reckon, at this point. All right, so we have voltage. Let's follow our wires around and make these connections. We have positive goes to the first resistor. Positive to the first resistor. Now we have positive goes to the second resistor. So there's 2 ways you could do it, but what we're going to do is we're going to go from here and go to the next resistor. And then we have, you can follow this wire again, goes to the third resistor. So you can click here and go to the third resistor. So it looks like one wire. I've made it like the schematic, but if you move apart, you can see there's a wire connected. Move it, there's the wire. Move it, there's the wire. All right, now at this point, each resistor is connected to an LED. So anode, anode, anode. So we're going to do that. We're going to go straight down and go anode, anode, anode. They're not straight. If you want to, you can straighten them up. Doesn't matter. All right, now at the cathode end of each of these LEDs is connected to each other and then back to the negative side of the battery or ground. So we're just going to go 1, 2, 3. And then when you simulate, again, the 3 LEDs should turn on. All right, so this is how these schematics look. This is what it would look like on a breadboard if you were to build it on a breadboard. Notice they're all in line. So we'll teach you that lesson later, but this is just to help you how to read schematics.